Okay, so the world of AI is just exploding with these incredibly powerful new models. But here's the thing, actually using them can be super confusing, really expensive, and honestly pretty unreliable. Today, we're going to look at a new system called MSS Plus that's basically a genius-level fleet manager for AI, designed to make these tools way cheaper and a whole lot more dependable.
So here's our game plan. We'll kick things off with a big problem, what I'm calling the AI model traffic jam. Then we'll get into the tug-of-war between what users, providers, and businesses all want. After that, we'll introduce MESS Plus, the smart router that brings some order to the chaos, and we'll even peek under the hood to see how it thinks. And of course, we'll look at the proof, the actual cost savings, and wrap up with why all of this really matters for the future of AI.
All right, first things first, let's paint the picture. Right now, we are stuck in a massive AI model traffic jam. The highway is just packed with all these different options, but there are no signs, no GPS, nothing telling you which way to go. And that is the absolute core of the problem. You know, imagine you've got a job to do, but you're faced with what the experts call a model zoo. This huge, chaotic garage filled with hundreds of different tools. For any single task, how do you know if you need the tiny, delicate screwdriver or the giant, heavy-duty sledgehammer? If you guess wrong, you either fail the task or you end up paying a fortune for a tool that was way too powerful.
Now this frames the problem perfectly. Think about the AI providers like they're a giant rental car agency. They've got a whole fleet for you. You've got your little scooters, right? The small models that are cheap and efficient, but, not super powerful. Then you've got your everyday sedans, which are versatile and pretty good for most trips. And then you've got the giant trucks. These are the huge 70 billion parameter models that are incredibly powerful, but man, they cost an absolute fortune to run.
So, having this whole fleet of vehicles immediately creates a big problem, a real conflict of interest. It's like a three-way tug-of-war between the people using the AI, the companies running the models, and the businesses that are actually footing the bill. And here's how that breaks down. As a user, what do you want? You want the best possible answer every single time. You're basically yelling, give me the truck for every trip, I don't care about the cost. But the service provider, the one paying for all that power, they want to keep their costs as low as possible. Their motto is basically, everyone gets a scooter. And then you have the enterprise, the business, stuck right in the middle. They just need a reliable balance. They have a contract to live up to, but they have to do it for the best possible price.
So, how does everyone agree on what to do? Well, they use a contract called a Service Level Agreement, or an SLA. Think of this as the official rule book. It doesn't promise 100% perfection. Instead, it guarantees a minimum level of quality. So, for example, it might promise that your AI tool will get the job done right at least 90% of the time. This gives everyone a clear, shared target to hit.
And this brings us right to the big question, doesn't it? How on earth do you build a system that can automatically follow those SLA rules, hitting that quality target just right, while saving as much money and energy as it possibly can on every single request?
Well, the researchers behind this new system, MSS Plus, they asked that exact question. They weren't just looking for a good guess. They wanted to build a provably optimal algorithm, something that could solve this super complex puzzle automatically and, this is the key word, rigorously.
And here it is. This is their solution. MSS Plus is an online algorithm, meaning it learns and adapts in real time. It's that brilliant AI fleet manager we've been talking about. For every single task that comes in, its job is to instantly pick the cheapest vehicle, the scooter, the sedan, or the truck that it thinks can get the job done, all while making absolutely sure the fleet's overall performance never, ever breaks that contractual promise.
Okay, so let's pop the hood and take a look at the system's brain. The real secret sauce of MSE Plus is its incredibly sophisticated, real-time decision-making process. For every single request that comes in, it all boils down to three main steps. First, a little scout model takes a quick look at the task's difficulty and predicts the odds of success for each model in the fleet. Second, an accountant checks the performance scorecard. Are we on track to meet our SLA promise? And finally, the fleet manager takes all that information, the scout's report, the accountant's warnings, and the cost of each vehicle, and it uses this powerful optimization framework to make the single best choice, balancing quality against cost.
Let's look a little closer at that scout. This isn't one of the big expensive models. It's a much smaller, cheaper, lightweight model, and it's constantly learning. With every single request, it gets a little bit smarter at predicting the probability that a specific vehicle can handle the next job. This is what lets the system be proactive instead of just reacting to failures. It's brilliant.
And here's the accountant's most important tool, something called virtual queues. Just think of it like a mistake counter or a performance debt tracker. Every time the system picks a model and it fails, the debt goes up. If that debt gets too high, it's like a warning light goes off, forcing the fleet manager to start making safer bets. Use the more powerful, reliable models to pay down that performance debt and get back in line with the quality promise. This is the core mechanism that makes sure the SLA is always met.
It's a really clever system in theory, right? But does all this complex stuff, the predictor, the virtual queues, the optimization, does it actually deliver in the real world? Well, the researchers put it through its paces.
And the results are, well, they're pretty incredible. Across a whole bunch of industry-standard tests, MESS Plus delivered, on average, a 2x cost saving. Let me say that again. It was twice as cost-effective as other really advanced routing methods, all while meeting the exact same quality guarantees.
You can see that advantage so clearly on this chart. We're looking at the average energy cost here. MS Plus comes in at just about 1 megajoule. Its next best competitors, they're both costing nearly double, over 2 megajoules, to achieve the same level of quality. It's not even close.
And this table tells us exactly why it's so much more efficient. Check this out. For this specific task, the quality target, the SLA, was 80% satisfaction. Now look at the other routers. They way overshoot the target, hitting over 86%, but at a super high cost. Why? Because they're using the expensive truck way too often. But MSS Plus, it intelligently mixes and matches the whole fleet to land almost perfectly on target at 82% for less than half the cost. See, it's not about being perfect. It's about being just right to meet the contract efficiently.
So what's the big deal? Why should we really care about all this super technical behind-the-scenes optimization stuff? Well, the impact is actually huge.
When you zoom out, the big takeaway is fourfold. 1, this makes AI more affordable. Lower operating costs mean cheaper services for all of us. 2, it makes AI more reliable. With guaranteed SLAs, developers can finally build products that we can actually depend on. 3, and this one's so important, it makes AI more sustainable. By always picking the most energy-efficient model for the job, it dramatically shrinks AI's massive environmental footprint. And finally, it's a foundation for the future. It proves that AI is getting smart enough to manage its own incredibly complex operations.
And that really leaves us with a final thought, doesn't it? We get so focused on the flashy, creative things AI can do, but this kind of research shows that it's the boring, logistical intelligence in the background that really unlocks the future. So if we can teach an AI to manage its own multi-million-dollar operations this well, what's the next huge, complicated system we're going to trust it to run for us?